Cosmology's standard model is one of the most rigorously tested frameworks in human history. It accurately maps the cosmic microwave background to a fraction of a degree and predicts the distribution of galaxies across billions of light-years with remarkable precision. This chart shows the composition of the universe according to that same model. The ordinary matter we can actually observe, everything we have ever touched, seen, or measured, makes up only 5% of the cosmos. The remaining 95% consists of undetected mathematical ghosts. Roughly 27% is attributed to dark matter, a hypothetical invisible mass required to keep galaxies from flying apart. Another 68% is assigned to dark energy, an unknown repulsive force proposed to drive the universe's expansion. Neither has ever been directly detected by any instrument. The situation worsens when physicists attempt to calculate the energy of empty space. Quantum field theory predicts a specific value for this vacuum energy, but when compared to the observed cosmological constant, the mathematical term driving cosmic expansion, the prediction exceeds the observation by a factor of 10 to the power of 120. A discrepancy of 120 orders of magnitude stands as the largest quantitative failure in the history of science. Modern cosmology has constructed a mathematically flawless map of the universe, where the continents are drawn with exquisite precision, but the oceans between them are filled entirely with phantoms. For decades, the response to this crisis has been to build more sensitive detectors and search for new particles. But the math suggests the flaw isn't in our instruments. It traces back to a single human assumption made half a century ago. To locate that assumption, we have to examine Einstein's field equations, the bedrock of general relativity. In their original form, these equations elegantly balance two distinct concepts. The left side of the equation represents geometry, specifically the curvature of spacetime. The right side represents energy and matter, the physical contents residing within that spacetime. Notice where the cosmological constant, represented by the Greek letter lambda, sits. It is on the left side. In Einstein's framework, lambda is an intrinsic property of spacetime curvature. It dictates how spacetime folds. It is not a physical substance. The break occurred in 1967. Soviet physicist Yakov Zeldovich observed that the quantum vacuum, the lowest energy state of all physical fields, has a mathematical structure that looks identical to the cosmological constant. Because they looked the same on paper, he assumed they were the exact same physical thing. That unproven assumption forced the cosmological constant out of the geometry column and redefined it as a physical energy filling space. This video explores the result of undoing that assumption and completely separating the geometry of spacetime from the quantum field. Returning these variables to their original locations allows for a cosmological model built entirely on established physics, removing the need for invisible substances. If we decouple vacuum energy from the expansion of the universe, we have to ask what this vast reservoir of energy is actually doing. Einstein's equation, E equals mc squared, dictates that energy and mass are equivalent. Because mass gravitates, energy must also gravitate. Therefore, the energy of the quantum vacuum must exert a gravitational pull. To see how this works, we look at the smallest scale of ordinary matter. Inside a single proton, we find 3 quarks. But when physicists measure the mass of those 3 quarks, they account for less than 2% of the proton's total weight. The remaining 98% of a proton's mass is derived from the energy of the seething quantum vacuum trapped inside it, a component known as the chiral condensate. This nuclear physics scales up. Because vacuum energy provides almost all the mass of a single proton, when trillions of stars and gas clouds clump together to form a galaxy, they drag an immense amount of this heavy, localized vacuum along with them. At the edge of a galaxy, 2 distinct environments meet. The unperturbed, free vacuum of empty space presses inward against the dense, bound vacuum swirling inside the galaxy. This creates a massive pressure differential, identical to the Casimir effect measured in laboratories. When you apply the exact nuclear coupling constant measured inside a proton, roughly 0.005, it perfectly predicts the extra gravitational pull and rotation speeds we observe in galaxies. The rotational speeds measured in galaxies match the calculated gravitational weight and inward pressure of the quantum vacuum coupled to ordinary matter. If vacuum energy is responsible for local gravity, we still have to account for the remaining 68% of the problem. What is driving the accelerating expansion of the universe? We must return to the blue side of Einstein's field equation, the geometry. The solution requires us to stop treating empty space as a magical fluid inserting negative pressure. Instead, we apply a model explicitly endorsed by Einstein himself, the block universe. In this framework, time does not flow. It exists as a static, four-dimensional structure, where the past, present, and future are simply different coordinates on a grid. Within the block universe, spacetime behaves geometrically like an elastic membrane. This requires reframing our origin point. The Big Bang was not an explosion. Instead, it is a temporal pole of maximal elastic deformation, a state where the spacetime membrane was folded and stretched to its absolute physical limit. What we experience as cosmic expansion is a process called metric relaxation. It is the kinematic illusion of this severely deformed spacetime membrane passively unwinding and returning to a flat ground state. This theory is testable. Recently, the Dark Energy Spectroscopic Instrument, or DESI, began mapping the expansion history of the universe with unprecedented precision. The DESI data indicates that the force we call dark energy appears to be weakening over time. While this contradicts the standard model, it is the exact behavior you expect from a physical elastic membrane losing momentum as it approaches its flat equilibrium. The accelerating expansion of the cosmos is the kinematic result of a geometric stage unwinding to equilibrium, a process described entirely by the stiffness of the spacetime membrane. If the spacetime membrane is relaxing and stretching in all directions, a severe paradox arises. Why doesn't the Earth, the Sun, or your own body expand along with it? General relativity provides a clear rule. Gravitationally bound systems do not participate in expansion. Any system held together by gravity or molecular forces maintains its own internal geometry. To visualize how this applies to the entire universe, consider the architecture of a tufted door. The leather is stretched over a rigid backing, pinned in place by deep buttons, with thick folds connecting them and smooth bulges of fabric in between. In the cosmic web, those heavy buttons pinning the membrane down are the supermassive black holes at the centers of galaxy clusters. They act as temporal anchors, holding the structure rigid against the primordial conditions of the early universe. The deep folds connecting the buttons are the filaments of the cosmic web. Galaxies slide perfectly intact along these dense curvature channels. The smooth bulges between the folds are the cosmic voids. Metric relaxation, or what we measure as expansion, occurs exclusively in these empty, unpinned regions, where the spacetime membrane is free to flatten. Bound structures like our solar system do not fight the expansion of the universe. They are simply deep curvature wells sliding coherently along a flattening background. The universe is not blowing itself apart. It is a single, self-preserving, intricately anchored crystal, sliding toward total structural stillness. By identifying and undoing a single mathematical category error made in 1967, the deepest crisis in modern cosmology dissolves. We can account for the 95% of the missing universe without inventing a single new particle, hidden dimension, or mysterious force. Every variable required by this model, from the coupling of the vacuum to the elastic stiffness of the membrane, is derived directly from established nuclear physics. There are no free parameters artificially tuned to force the equations to work. The derivation of the coupling constant alpha connects the microscopic energy of the nucleon to the macroscopic architecture of the cosmic web. We do not inhabit an incomprehensible void governed by theoretical phantoms. We live in a completely normal, structurally necessary universe where energy is mass, mass gravitates, and the geometry of spacetime relaxes exactly as Einstein's uncorrupted equations predict.